Hello viewers, myself Professor T. Anojha, again presenting to you a new video titled Compton Effect. We will learn in this video Compton Effect is an experimental proof of the corpuscular nature of electromagnetic radiation. And among the pillars of quantum mechanics, the points which led to the development of quantum mechanics, Compton Effect is one of them. We will study Compton Effect under the following heads for the sake of simplicity. Introduction, theory of Compton effect, the probability of Compton effect, particle-particle collision and mathematical formulation, Compton shift and Heisenberg's uncertainty principle, dependence of Compton shift, that is delta L, where L is wavelength, on the scattering angle theta, applications of Compton effect. These points will be discussed one by one in a bit detail. First point, introduction. A little bit about the scientist himself. Arthur Holly Compton was his full name. In 1922-23, he discovered the phenomenon of scattering of high-frequency photons, such as gamma rays or X-rays. There is a collision between the photon and outer orbital electron on the surface of the target. Electron, as you know, is electrically charged minute particle. As a target, we can use carbon or some other light element. This phenomenon of Compton shift is manifested by a decrease in the frequency of incident radiation. That is f prime less than f0, where f0 is initial frequency and f prime is the emergent frequency after collision. If we want to say the same thing in terms of wavelength, we can say there occurs an increase in the wavelength. When we say frequency, there occurs a decrease in frequency. But when we say wavelength, there occurs an increase in the wavelength. This is designated as Compton effect. Compton effect, again I describe, when photon strikes an electron, then the incident frequency is decreased, or we can say incident wavelength is increased. This Compton effect provides an experimental proof of the corpuscular nature of photon. For electromagnetic radiation, two theories are there for propagation. One is continuous wave form, and the other is discontinuous photon form, corpuscular theory. Both theories are in existence. Certain properties are understood in terms of wave nature. Certain other properties are understood in terms of the particle nature, photon nature. What is the cause of Compton effect? Cause of this scattering is this. The incident photon, written as F0, H is Planck constant, collides with an outer electron. Thereby, part of its kinetic energy is transferred to the recipient electron. Or we can say that both energy and momentum are transferred to the charged electron, while the photon gets deflected and moves off with a reduced energy and change of momentum. I repeat this point. When photon collides with electron on the surface atom, what happens? Part of kinetic energy and part of momentum of photon are transferred to the electron. As a result, the photon that emerges after collision has lower frequency, has reduced energy, increased wavelength. The electron is forced to recoil from the position of impact. The energy of the deflected photon equals the energy of incident photon minus the sum of the kinetic energy gained by the recoil electron and its binding energy. Repeat this point. The electron is forced to recoil from the position of impact. The energy of the deflected photon equals the energy of incident photon HF0 minus the sum of the kinetic energy gained by the recoil electron and its binding energy BE. Later we will learn that the Compton effect also provides an experimental proof of the Heisenberg's uncertainty principle. A very important point to note here. Let us now pass on to the theory of Compton effect. Similar to the photoelectric absorption of photon, Compton scattering results in the emission of an electron from the absorbing atom. You may recall in photoelectric effect what happens? Absorption of photon results into ejection of electrons with certain kinetic energy. The same point is being said here. Similar to the photoelectric absorption of photon, Compton scattering results in the emission of an electron from the absorbing atom. They are always surface atoms, not the interior ones. This results in the change of path of the scattered photon, causing further ionizations and often exiting the target. The recoil electrons also suffer loss of their energy by ionizing other atoms. You remember in the beginning I told you high energy radiations are used to study Compton effect. An important observation of the experiment was that the wavelength is not dependent on the intensity of incident radiation. Wavelength is not dependent on the intensity of the incident radiation. Further, the shift in wavelength is not dependent on the nature of the substance. 2 points. The after the shift wavelength increases, and this increase is independent of the nature of incident radiation as well as independent of the nature of the substance. Let us now pass on to the probability of Compton effect. How much probable it is? It is directly proportional to the electron density of the absorber. The probability of Compton effect is directly proportional to the electron density of the absorber. For example, when biological samples are used, bones having greater electron density than soft tissue provide greater probability of Compton scattering than soft tissues. As a result, Compton interactions also contribute to the formation of an image. It has been estimated that 57% of interactions in a dental X-ray beam exposure involve Compton scattering. So this was about the probability of Compton effect. Particle-particle collision and mathematical formulation. In the beginning, I have told you, Compton effect provides ample evidence that electromagnetic radiation is corpuscular in nature. Electron is also a particle. So collision between the incident photon and electron is the main cause of this phenomenon. The physics of Compton scattering can be treated as a particle-particle, that is HF0 and electron interaction. And if the electron were a free particle, since the binding energy is small compared to the photon energy, HF0, let the photon be scattered at an angle theta relative to the incident direction, and let the electron be ejected at an angle phi relative to the forward direction. These points are very much clear in the following diagram. In first diagram, the photon HF strikes the surface of the metal or non-metal, whatever target we are using. It collides with an electron marked by a circle with a negative mark inside. Then electron is forced to get ejected, and the incident photon gets scattered with energy lower than HF. This lower energy is shown as HF prime. And the two angles are shown here. Scattering angle is theta, and ejection of electron is shown by the angle phi. The next diagram is very much similar to the first one. Just for clarity, I have shown two diagrams. There is not much difference between the two. The only thing is the formula is written below the diagram. L prime is the wavelength after scattering. L is initial wavelength. Difference is delta L. And this can be shown as equal to h upon mc multiplied by 1 minus cos theta. H you know, Planck constant, m is rest mass of electron, c is velocity of light. So these two diagrams are self-explanatory. They reveal what is happening in Compton effect. A few more points. By applying the principle of conservation of energy and conservation of momentum, it can be shown that the Compton shift in wavelength equal to delta L is 2h over mc multiplied by sin square theta by 2. Equation number 1. In this equation, as I told earlier, m is the rest mass of electron, which is 9.108 into 10 to the power minus 31 kilogram. C is the speed of photon, exactly 2.9979 into 10 to the power 8 meter per second. Theta is the angle between the incident and scattered photon. Equation 1 shows that the shift in wavelength delta L should be independent of the wavelength of the incident radiation. I clarify further. The shift in wavelength is independent of the wavelength of incident radiation. Experimental findings were found in agreement with this inference. The magnitude of change in wavelength delta L calculated by equation 1 and that found by experimental analysis were in good agreement. You know, A.H. Compton was a physics Nobel laureate of 1927. Compton shift and Heisenberg's uncertainty principle. When particle-particle collision takes place between the incident photon and the electron, both energy and momentum are transferred from photon to electron. I repeat, when photon collides with the electron on the surface atom of the target, what happens? Both energy and momentum are transferred from photon to electron, not wholly, part of it. Obviously, the momentum of the electron must have changed during the process. Consequently, it cannot be determined with certainty. The Compton shift can also be written as equation 2. In this equation, delta L is equal to h upon mc, 1 minus cos theta. The change here related to equation 1 is based on trigonometric identities. So, this point to be clarified again, the Compton shift is in agreement with Heisenberg's uncertainty principle. Now, dependence of Compton shift delta L on the scattering angle theta. Three conditions have been laid down here. Condition 1, when theta is 0 degree, that is, scattered radiation is parallel to the incident radiation, there occurs no wavelength change. Because if you look at equation 2, cos 0 degree is 1, 1 minus 1 becomes 0, the whole thing delta L becomes 0. So I repeat, when scattering takes place by 0 degree, then no Compton shift occurs. Second condition, when scattering is at 90 degree of the direction of the incident radiation, that is theta equal to 90 degree. And you know cos 90 degree is 0. Therefore, delta L becomes equal to h upon mc. If you put the values of constant h, m and c and calculate, it comes out to be 0.0242 times 10 to the power minus 10 meter. That is 0.0242 angstrom. This shift is usually called Compton wavelength. Very important term. The photon is scattered at 90 degree relative to the incident beam, and this is scattering is known as Compton wavelength. When theta is 180 degree, and you know cos 180 is minus 1. So again looking at equation 2, delta L becomes equal to 2hmc. That is twice the value when theta is 90 degree, and calculation comes out to be 0.0484 angstrom or 0.0484 into 10 to the power minus 10 meter. So this was about Compton effect. Regarding applications of Compton effect, it is applied in most fields, physics, chemistry, especially in medical imaging, and in understanding electron momentum distribution, in understanding Mossberg spectrometry, also called gamma ray spectrometry. So the phenomenon of Compton effect has been immensely used in various fields. I repeat, gamma ray Mossberg spectrometry in analyzing electron momentum distribution, and for its role as major cause of image contrast in medical and industrial radiography. A few lines about the scientist himself. Arthur Holly Compton was born on 10th September 1892 and died on 15th March 1962. He was an American physicist. He discovered the phenomenon of scattering a photon in 1922-23, and he was awarded Nobel Prize in 1927. So, viewers, I am trying to help the learners by providing these videos, verified contents. Sometimes during my teaching tenure, I found students feel agitated in learning these points. They presuppose that these things are very difficult, but these are not difficult at all. And one more thing, understanding these fundamental observations enables you more, strengthens your views, and prepares you for understanding modern quantum mechanics. So I suggest, please set away your hesitations. The pillars of modern quantum mechanics: photoelectric effect, Compton effect, black body radiation, quantization theory. All these things should be well understood. There is no much mathematics involved. Simple equations, simple descriptions. Yes, 2, 3 readings are necessary to understand these things. And as a part of paying honor, we should also know a little bit about these persons who discovered these concepts. So thank you very much. I hope you have understood these things. You can watch this video 2, 3 times, take notes, and we will definitely learn about it.